All right, I'm going to try to explain to you how to write the electron configuration for an element. And in order to understand that, you first have to know where the blocks are on the periodic table. So group 1 and group 2, this is considered the S block. Groups 3 through 12, this is the D block. Groups 13 through 18, this is the P block. And down here, the lanthanide and actinoids, these down here, are the F block. Okay? And you wouldn't write this on your periodic table, but just so you know how I'm going to count this, this would be S1, this is S2. Going across here, this would be D1, D2, D3, D4, D5, D6, D7, D8, 9, and 10. Up here, this is P1, 2, P3, P4, P5, and P6. And then F, this is F1, and it goes all the way across, and this would be F14. So kind of the best way to do it is just to start. So I'm going to say, okay, let's write the electron configuration for oxygen. Now, when you start, you want to walk, what I say is like walk across the periodic table, or move across the periodic table, or move numerically across the periodic table until you get to the element that you're going to try to write the electron configuration for. So I'm going to start here at hydrogen, I'm going to move across to helium, and then lithium, beryllium, and all the way over till I get to oxygen. So for the electron configuration for oxygen, I would start with 1s2. So this 1 right here tells me that it's the first energy level and that I've made it completely through the S block. Now this is kind of confusing because helium's over here with the noble gases, and they put it over here because it is inert, which means its outermost energy level is filled, so it does not react like the rest of the noble gases. But in actuality, it has 2 valence electrons, so you can kind of picture that helium would belong right here. And so helium with its 2 valence electrons would have moved through the 1s2 orbital. So as I move through, it means I got all the way across through the s orbital 1s2. And that takes care of that first period. Now I'm trying to get to oxygen, so I need to go down again. So now I'm in my second energy level. I make it through the entire S block, so I'd write S2. And as I move into the P block, they want me to say again that I'm still in my second energy level, but oxygen is actually going to be in the P4, so I'd write 2P4. So this is for oxygen. And oxygen, you can see, has 8 electrons. So if I want to double check this, I can add my superscripts up here. This 4 plus 2 plus 2 gives me 8 electrons, so oxygen has its 8 electrons. So these numbers in front tell me the period, or what energy level it is, and the blocks tell me where specifically each of those electrons are. So let's do another one. Let's say we want to write the electron configuration for aluminum. Okay, so I'm going to start again at the beginning of the periodic table, my first energy level. I make it through the S block, S1 and S2. I'm not going to write both, I'm just going to write that I made it all the way through to the end, S2. That takes care of this. The next, I get down to my second energy level. I made it through the S block, so it's 2s2. I move into the P block, so I have to restate that I'm in the second energy level. I'm going to make it through the entire P block, which gets me to P6. I still haven't reached where I want to go, aluminum. I think that's what we were doing. So I need to keep going down to my third energy level. I make it through the S block, so I write 3s2. And now I'm back in the P block, so now I would write 3p, but aluminum ends with 1. So aluminum has 13 electrons, so if I add up 2 plus 2 plus 6 plus 2 plus 1 will give me 13 electrons. So this is the electron configuration for aluminum. So those are pretty simple. But then we get down into this D block. And what you have to know about the D block is that you have to write next to your D that n minus 1 is here. And next to your F block, you need to write n minus 2. And then it's helpful if you write that n equals the number of energy levels. So what happens is that if I'm going to look at my D block right here, you would think, okay, this is the 4th energy level going across. But when I'm in my D block, it's not the 4th energy level because I need to subtract 1. This is actually the 3D for the fourth, or for this group of elements. Moving down here, instead of this being 5D, I have to subtract 1, so this is actually the 4D group. Moving down here, I have to subtract 1. This is going to be the 5D, and this would be the 6D. So let's see how that works if I was to write the electron configuration for copper. Okay, so again, I'm going to start at the beginning of the periodic table, and I'm going to start walking across. So I start with my first energy level. It's going to be 1s2. All of these are going to begin with 1s2 unless it's hydrogen. It's just 1s1. And helium is 1s2. If you're going past helium, all these electron configurations always start with 1s2 because you made it through that first energy level in that s block. So I'm trying to do copper, so I'm going to keep going. So I have 1s2. I'm down to my second energy level. I make it through the s block, 2s2. Now I'm in my p block, so they want me to write 2 again and say that I make it all the way through the p block, so it would be to p6. I'm down to my third energy level. I make it through the s block, so 3s2. I'm over to my p block now, so I need to restate it. 3, third energy level, p6, which gets me all the way over here to argon. And then I go down to my fourth energy level, which would be 4s2. And then to get over to copper, you might be tempted to write 4d9. But remember, when you move into the d block, you have to subtract 1 from that energy level. So it's actually 3d, and if I count over, it would be 3d9. So this is the electron configuration for copper. Now, this is kind of long. So we have a nice little shortcut way that we can write this. Is called noble gas notation. And what you do is you go to the previous noble gas. So as I was on my way to copper, the last noble gas that I walked on or passed through was argon. So I would put argon in my square brackets, and that would take care of those 18 electrons. And so that would take care all the way up to 3p6. All of that is taken care of by writing argon in square brackets. Then I would just go on from there. So after argon, I would say, okay, I have 4s2, and then on my 3d9 block. So this would be the noble gas notation for copper, which is a lot shorter than writing the electron configuration for copper, which would be that. Just one more example, because down here in your F block, you have n-2. So if I was to try to write the electron configuration for lead, okay, I would want to, let's just do the noble gas notation. I would go to my last noble gas, which would be xenon. So I'd put xenon in my square brackets, and that takes care of those 54 electrons. And then I would continue on. So continuing on, I'm in my 6th energy level. I get through my S block, so it's S2. Now it's kind of tricky because remember my lanthanides, you know, this is atomic number 57. Here's number 58 through 71, and here's 72 right here. So all these elements are actually in between lanthanum and hafnium. So you might be tempted to say, okay, I'm going to do this D1, and then go down and do all my Fs, and then go back and finish my Ds. But you don't want to do that. You want to keep all of your blocks of elements together. So what you're going to do is you're going to go 6s2, you're going to go down and do your F block. But remember, F is n-2. So instead of 6, this is actually the 4F, and this would be here with 7, so this would be the 5F. Okay, but I don't need that to do lead. So here I have my 6s2, so I ended with xenon, 6s2, then I would go down and do 4F, and all the way across is 14. Then I would go back to my D block, which is n-1, so it would be 5d10. Then when I get back to my P block, I go back to what the energy level is, so this would be 6p2. Oh my goodness, so you can't see that. So that is the electron configuration for lead. Now, valence electrons are only found in the s and p orbitals. So I have to look here at all my energy levels, and remember, valence electrons are the electrons that are the furthest away from the nucleus or in the highest energy level. So I look here and I compare my 6, my 4, my 5, and my 6, and my highest energy level is my 6 energy level. So I would say, okay, I need to add the s and p orbital electrons to figure out my number of valence electrons. So 2 plus 2 gives me 4 valence electrons, and if we look on our periodic table, it's in group 14, which has 4 valence electrons. So this is for lead, and it has 4 valence electrons because I've added my S and my P and in my highest energy level. Now, what kind of question are you going to get on the test? You're going to just be given an electron configuration and asked to identify what element it is. So if I was to give you this electron configuration, what element is it? Well, there's a couple ways you could do it. You could add the number of electrons this element has. So 2 plus 2 is 4, plus another 4 is 8, and you find on your periodic table the element with 8 electrons, and you would say, oh, that's oxygen. Or you could look at the very last part here, and it says this element is in the second energy level, and it's in the P4 row, which is P1, P2, P3, P4. So that would say, oh, this is oxygen. All right? So if I was to give you a noble gas notation, oops, it has to be 5s2, sorry. 5s2. What element is this? Okay, so again, you could add up the number of electrons. Krypton has 36, plus 2 would give you 38, plus 9 would give you 47. Did I add that right? Yeah, 47. And so the element that has 47 electrons is Ag, silver. Okay, that's one way of doing it. Or you can look and say, okay, where's my 4d9? But what's tricky about that, you have to remember that you might try to call this the 4d because of this 4 energy level, but you have to say n minus 1, so this is your 4d actually right here, and then d9 would get you to silver. So on your test, you're not going to have to actually write the electron configuration. You're just going to be given an electron configuration and asked what element it is. The other thing is I can ask you how many valence electrons does this element have, and you'd have to remember that it's the electrons found in the highest energy level in the s and the p orbital. So this is my highest energy level is 5, and my s orbital would be that this had 2 valence electrons.